is that we are trying to combine geotechnologies and sustainable development. By using modern geoinformation technology, as well as geoecological field and laboratory methods to analyze, communicate, and sustainable develop UNESCO sites, but not just UNESCO sites like World Heritage or Biosphere Reserve, but also a different kind of, let's say, landscapes. And we have two center of competence and learning labs. The one is the GIS station. It's a competence center for digital geomedia. And the other one is the GECO lab. It's the center of competence for geoecological space exploration. And both are covered by the Heidelberg Center Education for Sustainable Development, where we try to combine education and sustainable development in different fields of research, but also application and teaching. And as I said before, one of the core profiles of our university is to be a model university to foster the SDG, but also to foster education for sustainable development. And this is also something where our project in the Atacama Desert is situated. It's somewhere in between SDG 13, which means climate and climate change, climate action. But we are also dealing with SDG 6, which is about clean water and sanitation. But also other SDGs are covered within our project, where we try to figure out how fog can be used as a natural water resource. For example, no poverty, but also sustainable production in agriculture, for example, or other aspects are covered by our research, which we are doing in the Atacama Desert. So this is just my part of the presentation for the moment as introduction, and I'm passing over to Juan Carlos, who will give you a more in-depth insight in what we are doing in the Atacama and what could be linked also to other regions in the world. Please.
Thank you, Sigmund. Hi to everyone. So this is our contents. First, we talk about the background of fog as a water resource worldwide. After that, the fog measurements worldwide, especially in the Atacama Desert. The third part is related with our network, the fog climate network in Atacama Desert. Finalizing with the fog water as a resource in northern Chile, and our future perspective of the fog research in this part of the world. So there are historical and natural precedents on the importance of fog as a water resource, realizing its potential as a vital source of water around the world, especially if we consider we live in natural environment under pressure and often adverse socioeconomic conditions. This map shows the world's desert areas and non-polar lands with relative degrees of aridity. These lands have one of the harshest environments on Earth, covering large areas on all continents. For example, we work in the Atacama Desert in the southern hemisphere. The Atacama Desert is the aridest place on the Earth, recording 400 years without precipitation, without rainfalls. And in the same hemisphere, we have the Namib Desert, one of the driest deserts in the world. So these two deserts have one special condition. They have fog in their coast because the work of the variability of the currents in front of the coast. So we have a very important resource of water in this kind of environments related with arid lands. Very few species survive in the desert, especially in the Atacama Desert, the aridest place on Earth. This can survive in this kind of survive needs water, especially water to survive, to do everything related with their behaviors in the desert. But it's in this coastal desert where fog and the condensation are a reliable source of water, while precipitation is unpredictable. Due to global warming and increased period of drought, water supplies continue to shrink. This map shows the water withdrawn annually, fresh water, and we can see the inequalities in the world. So especially this is the stats of water around the world, showing the percentage of fresh water. More than 2 billion people, the world representing almost a third part of the world, live in countries with stress of water supplies. Stress levels will continue to rise as demand for water grows and the effects of climate change intensify. Most people affected by water stress live in North Africa, the Middle East, but also in the United States, we have areas with the stress, water stress. This global map provides a picture of water availability in relation to demand, especially related with the socioeconomic activities in the world. And this relationship, water supplies and the socioeconomic activities, is key since dry areas may not have high demand and therefore little shortage. What is immediately evident is that many areas of the world have abundant water relative to their use, as we can see in Europe on the different in the different hemispheres, northern and southern. Globally, there is little information on the extent to which water considerations are driving investment in the world. However, there will undoubtedly be substantial pressure on civil society and business to address water issues if the country plans to continue attracting new investment dependent on water, especially in the developing countries. So we know that circa 70% of the Earth's surface is covered by water. Most of the water is contained in the oceans, and fresh water represents only about 2.5%, as shown in the figure. Earth's atmosphere contains approximately 0.001% of global water. It's found in the form of clouds, fog, and water vapor. It's a small amount, very small amount in global terms, but it represents about 3% of the water in rivers and lakes, so which is important source of drinking water. In fact, in arid deserts, many plants and animals survive by collecting water from the atmosphere. The image on the left is a record from the end of the 16th century. It's about the Garoe tree in the Canary Island, adored by the ancient inhabitants on the island, the Bimbaches, a symbol of island identity. The leaves of this tree collect enough water from fog to supply the entire local population and their supplies, which made it become a sacred tree in those times. In the image on the right, the same island, the Canary pine, or Pinus canarius, has been vital importance for the Canary Islands in water collection. So it grows in the cloud forest belt, where rainfall is usually around 50%, but under the trees, this height increases to 200 with the fog dripping from the leaves of this kind of trees. This is a precedent, historical precedent, and it's a precedent, the pine, the Pinus canarians, but it's until now. And this other image corresponds to a project carried out in the Moroccan desert, which sought to provide hot water to satisfy the basic needs of the small towns. Just like this type of projects, there are many around the world, and especially in developing countries with water shortage problems and scarcity, especially in the developing countries, as I told you. So this was the introduction. Now the background of fog measurements worldwide, taking in consideration the importance of fog and its measurement as a relevant matters, and various attempts have been developed worldwide. So we will show you some of these kind of attempts. This is the pioneer and the most widely used device around the world for measurement for collected. It's called a standard fog collector. This consists in 1 square meter is a metal frame covered with a racial mesh placed at a height of 2 meters. The plastic net is exposed to the action of the wind southwest in the Atacama Desert, like in the picture, and collect the data, in this case, in the right image, every 10 minutes, and send the data to our central repository in the city of Heidelberg, in this department. So these are the projects done and ongoing related with fog and dew around the world. We can see in the red dot the dew project, and in the blue dot the fog projects around the world. We can see the fog projects are especially ongoing in the southern hemisphere and in developing countries, like in South America or in Africa. And the dew projects are especially in Europe and the Middle East. And these are a proof of the importance of fog and the dew as a source of water and its measurement around the world. So this plot shows the rate of fog water collected around the world in different cities and the number of days that fog occurs annually. The rate of fog varies from 1.5 to 20 liters per square meter per day, and we can have fog throughout the year depending on the location, as we can see in the picture. The rate of water collection depends on several environmental factors, as we know, including the difference between air temperature and dew point temperature, wind speed, wind direction, and ground temperature, like the others. So this is a first panorama of the fog research in the world and the first panorama of fog measurements. So now we can see the special cases in the Atacama Desert. So let's delve into the fog climate measurement in our master site, the Atacama Desert in the northern Chile, and its relevance for the fog research around the world. This department, the Department of Geography, together with colleagues from the Atacama Desert Center in Chile, carry out a long-standing cooperation that seeks to better understand fog patterns and the relationship between atmosphere and biosphere in this kind of places. So the Atacama Desert is the driest place on the planet, which always is existent and particularity to the combined effect of the ocean and desert behavior. So it's in this kind of environment where fog plays a very vital role for the ecosystem and for the human settlements in the coastal desert. So with annual precipitation below the 2 millimeters, fog water supply is the main driver for ecosystem processes there. So in this kind of environments, we carry out a multi-approach research related with the behavior of the stratocumulus and its interaction with the biosphere in this kind of places. So our idea, finally, our goal, is try to understand the interaction between the atmosphere and the biosphere in this kind of places, in the extreme condition in the north of Chile. It's an area more than 1,000 kilometers north to south, but especially we are concentrated in the north, in the extreme north of Chile, with the ARIDEST condition in the world. So we can see in the picture the different approach related with the analyze based on the satellite images and analysis based on the climatological network there. So this is a video that recorded the behavior of the cloud in the coastal desert. This system is called GOFOS. It's based on 2 time-lapse cameras observing an altitudinal profile of autonomous LED lights, solar lights, and allowing us to to see the frequency and vertical variability of the fog, which allows us to complement the preceding information related with this kind of variability, the clouds in the desert. So through this record, we have been able to determine that there is a presence of fog of less than 10% during summer and 50% during winter, showing a daily variability in the presence of fog that decreases around noon and increases again in the afternoon. So we have more condition for fog in the early morning. Additionally, the observed vertical structure shows the depth of the cloud in this place is approximately circa 250 meters. So to meet the objective of this research and understand the fog climate there and its value as a water resource, a regional network of high temporal resolution of climate station has been configured since 2016 there. So these are the characteristics of each station installed in the desert. Currently, the fog climate measurement network has 8 climate stations, each with a standard fog collector, as we can see in the picture. These stations are located from the coast to 11 kilometers inland and up to 1,300 meters above sea level. The location of each station is markedly differentiated topographically, and the altitudinal gradient seeks to understand the atmospheric condition that produce or the variability of the fog in these kind of conditions. As we can see, we measure the standard fog collector is our main parameter measure there. But also we can see we measure the relative humidity or temperature and so on. We can describe the main station now. This is our main station in the desert and the different sensors there. We have the standard fog collector in the middle, and we have another sensors that measure the driving parameter to try to understand the fog climate in this place, in the ARIDEST place on the Earth. So this is a typical standard fog collector in the left side, in my left side, at least. We can see how the drops are flowing through the mesh in the standard fog collector. Is in a fog event there. But also we are implementing a new devices to try to understand the behavior of the variability of the fog events there. In my right hand, in the right image, we have a cylindrical fog collector, and we try to understand how is the fog collector in another condition than the standard fog collector. For example, the standard fog collector is in face of the southwest in the ATACAMA desert, and it's not possible to see in detail what is the influence of the wind direction, for example, in the fog collection. And we try to see, for example, the wind direction, the influence of the wind direction in the collection of the fog in the cylindrical fog collector or fog collectors 360. We can see also is flowing the drops in the different in the mesh. So this is a normal day in the desert. It's a video running. The sky is very clear and very calm. Typical day in the desert is a video running. We can see the wind direction, the wind speed sensor there working. A normal day in the desert, this represents almost 96% of our records. It's approximately 10 days of the year, finally. But also, it's another day in the desert. The video running is the day before that video. It's a fog event in the ATACAMA desert. It's not normal than the last video, but also is normal for this kind of desert, the coastal desert around the world. So we can see it's as I told you, it's a video running, and this represents almost 4% of records. And as I told you, it's data every 10 minutes. So every 10 minutes we can see collected in this kind of devices, we can see, okay, in other parts of the world, they are recording fog, or it's a fog event in the Atacama Desert. This plot shows the moisture condition in the Atacama Desert based on 4 devices there. The first device, the first plot is the fog water collector, then humidity over 70%, then leaf wetness over 70%, and the last one is the dew recorded. So we can see the variability over the year and over the day. We see most of the moisture condition for the fog are in the early morning for every device, and it's very strong, the relationship based on the season in the southern hemisphere. We can see there are more conditions for fog in spring and summer, austral summer and austral spring, but in the winter and autumn, austral winter and austral autumn, there is less condition for fog, or less condition for moisture or humidity, right, based on this kind of sensors. So now, fog as potential water resource in northern Chile. The idea here is, okay, fog collection can become a possible solution to water shortage or scarcity, and could be a viable and sustainable water resource, offering new perspective for development. So let's look at the case of the Atacama Desert. So, for example, Chile has a research center of high academic level located in the coastal desert, whose only source of water is the fog water collected by this kind of atrapanieblas in the first image in the left side. Or, for example, we even have beer made based on fog water, based on the atrapanieblas water. The Chilean beer called Atrapaniebla, produced in the north of Chile, which based on the official information from the company, is made with 90% of fog water collected. And also in the right hand, we have this national park in the north of Chile, and we can see a bathroom which unique source of water is the fog water collected in the Atrapanieblas behind. So these are some examples of how the fog water can be used.
Use the UHC action agenda and amplify.
In Chile, in this case, in the Atacama Desert. So a special case, very special case, is a case of a study around the world. The frog project of the Chongungo in the south of the Atacama Desert. This project began in 1987 with the evaluation phase, like in this paper. You can see now computational drawing. The work was carried out by a public-private collaboration, including universities. And in 1992, the group installed 50 fog collectors, and the Canadian Embassy provided funds to build the tubes to connect the Atrapanieblas with the community. And the system grew until there were around 100 fog collectors, 7 kilometers of pipes, storage tanks for the community, and they provide the fog water for this community almost 10 years without stopping for their basic activities, especially agricultural things or fishery or that kind of activities. So in the following years, ending the 90s or beginning the 2000s, the project and the actors involved no longer received management support from the public service. Consequently, administrative problems began, in addition to problems related to water distribution, damage of the fog collectors, and so on. So, finally, the maintenance of the fog collector was very expensive for the community, and the problems in the management between this community and the public sector was not possible to continue with this project. So, this project and finally by 2003, and now there are fog collectors, but not to supply the community, just for research. So we have a proposal from a professor of the Catholic University in Chile, based on installation on large frog collectors. The professor is Pablo Oces, is his proposal. And he describes the different towns in the north of Chile. This, like in the picture, he describes every community with his population, with his needs there. And his proposal is, okay, he identified the communities, the different needs. Okay, this community needs some quantity of fog collectors, large collectors there. And also he then identified the needs of fog water for each settlements there in different colors, and he made an exercise to propose the fog water supplies for each community there. It's a very interesting work there, and this is his proposal, also Pablo Oces. Finally, he identified how much fog water they need. So each community there needs this quantity of fog water for this kind of activities. So he defined every activity and every amount of fog collection for each community there. It's a very interesting work. If you want to visit it, or contact him with his proposal. So, future perspectives.
Yeah, let's finalize with two major future perspectives about fog as a complementary or alternative sustainable water resource. So one you can see on this picture, the aspect of the people, you know. Many of these projects around the world struggle with the problem that local people have not been involved in the project from the very beginning. So from the planning, from the decision to set up fog collectors, up to the training they need to maintain the fog collectors. So this is, I think, a very, very important issue, not just for fog collection, but in general for development, to implement, to include, to integrate the local people in such projects from the very beginning. And our idea is to do so by doing reviews, making questionnaires, doing interviews with the people in the northern part of Chile. Some of these reviews have already been done. Some of these questionnaires have already been spread to the people, because it's necessary to make them aware that fog water is really a natural and sustainable water resource, even for drinking. If you treat it in addition, you can use it for drinking, but for sure you can use it for agriculture issues or different other things. But people often are not aware about this natural resource, which is just in the backward side of their houses. Let's say on the top of the hills, you can find these fog oases, how they are called. And it's as you can see here, it's a quite easy technology. It's not expensive. You just need some stems. You need the mesh, and it's easy to put it up. It's easy to maintain. It does not cost much, and also the distribution of the water is quite easy. You can use the gravity from the mountain to the valleys where most of the villages are situated. So the water is just flowing down the hill in little tubes. And there's not much need of treating the water with chemicals or something, maybe just some filter to avoid the dust from the water. So it's a quite easy technology, but people must be involved. Another aspect I would also connect with this photo is the aspect of governance and the aspect of water rights. In Chile, we have the problem that the water rights are private. So the person who giving most of money gets most of the water. And as the area is an area where there are big mining companies producing lithium, where much of groundwater is used, but also copper and other resources, these companies have for sure much money and they own the water rights. and so the people on the coast often did not get enough of water for what they need. So the water right is an aspect, but also the governance of water. You must be aware that there are producers of regular water out of desalination plants. So the salt water is desalinated and it's sold to the people. And if they have a free of charge water resource like the Fork water, there's also some conflicts about that, because the companies who normally sell water are not so motivated to support such projects. So this is one of the aspects of future perspective. And the other one is an aspect of water scarcity. Here you can see the map. So the problem is that often there is an overlap of regions where there is less water, and maybe the water supply is already, or in addition, decreasing because of climate change. And on the other hand, regions where there's a high population density. So two problems are getting together: less water, which is supplied by nature, huge amount of population, often with high growing rates. But on the other hand side, there are regions, especially in the desert regions on the coast, as already mentioned by Juan Carlos, where we have fog, which is directly in the front yard of these coastal deserts like ATACAMA desert, but also Namib desert. The same is with desert in Australia, in California, and in the Near East. So there are many regions like that where fog is there, it's for free, and you can easily use it, but not too many projects have been successful until now to use this water as a natural and sustainable water resource. So this is our outlook for the further perspective. We thank you for your attention and are free, and for any questions you have, feel free to do so. Thank you very much.
Thank you very much. Thank you very much. Thank you.
I forgot one slide, but we can skip that.
Yeah.
Thank you.
I hope we have some questions maybe, but before opening the discussion, I have first of all, I would like to express my personal and our feeling about this wonderful presentation and job, and this is a really fabulous presentation regarding of getting water resources in deserts and in arid areas, and water scarcity is the real problem of nowadays. And one question is regarding of how you are fighting and what technologies you are using against evaporation of collected water from this dew and from fog. What kind of technologies usually are using to avoid evaporation of water? Is there special tanks or special reservoirs, and to avoid dust and contamination, and especially evaporation is a huge problem.
Yeah, it is absolutely. So there are different places where evaporation can take place. The first place, the mesh where the water drops situate. If it's not enough of fog water, which is situated on the mesh, there is evaporation, and this is reducing the amount of water you can harvest for sure. But we don't do nothing against it, because we say, okay, there's enough of fog coming through, and the wind speed is high enough, because wind speed is also an influencing factor. You need fog in the air, and you need wind speed, that the water or the fog is flowing through the mesh. So there's evaporation for sure, but nothing against it. Then we have the regular tube. It's a basic plastic tube to regular tanks. And there is for sure some evaporation on the way from the meshes to the tanks, but also in the tanks. But the tanks are 100% covered. So I would assume, we have not measured that before, but it's a good hint from you. Maybe we should do that in the future. That there will be for sure be some evaporation out of the tanks, but I think it's not much, because the tanks are 100% covered. So there are no open gaps in the tanks where water can evaporate. The other aspect you mentioned is the contamination of the water. For sure, we are in a desert region, so there is also dust, which is also deposited on the meshes, and if the water is coming, the water is let's say influenced by the dust. But in between the mesh and the tanks, we are implementing filters, regular filters, different cone sizes, where we can, I would estimate 90% of the dust and other contaminations, or the contaminations are on the dust normally, can be eliminated from the water. So
Thank you very much for this information.
It's all basic technology to keep it smart and simple and cheap, you know?
Yeah. Thank you very much for this showcasing the world situation about water, the situation of scarcity, physical water declining. What I mean, drinking water, and this is the real good alternative to combine traditional knowledge from peasants level to modern and advanced technologies together, integrate together, and to get these wonderful results within this country. And I really wanted to test this wonderful beer, and maybe one day we can test it together. So let me have another question from our audience. Miss Maria Joanna is asking about this presentation, and she expressed this wonderful feelings about this presentation. I was wondering, how can you compare the collection results from the SVEC and the 0 degree, since they in different medium?
Yeah. Okay. The idea behind is the following. So not the SFC, the standard fog collection, let's say the traditional way to measure fog, or to measure fog water income.
Sure.
But this is a fixed mesh which you have to place orthogonal to the main wind direction. So you need one main wind direction where the water is or the air is flowing through orthogonal. Yeah. But we recognize it on our place that the wind direction is that there's not one major wind direction, but the wind direction is from different directions. So, and also the fog is not just coming from the coast, what was described in the literature, but we observed that many of the fog events are coming from inland. We have been wondering, so inland is the desert, so where can the water come from? And the idea is, on the day, the water vapor from the coast is going inland, so it's a high humidity going inland, and during the night, the air is cooling down, the air starts to condensate. There is the development of fog inland, and we are land-sea wind systems. The wind is coming from the inland to the sea in the night, bringing that fog which has been developed by condensation inland. So we have different wind directions where fog is coming from, and we have been wondering if we get all the data on our SFC, because the SFC is sensitive to wind direction. So if the wind direction, for example, is not orthogonal to the mesh, but it's parallel to the mesh, you don't get any fog, you know, because the wind is going in parallel to the mesh. So you need an orthogonal way. And that's why we have situated and implemented this 360-degree SFC to be able to compare that measurements relatively, not in an absolute amount, relatively to our SFC. The idea is that we can make recalibration of the fog water amount in comparison to the wind direction if we combine the data from the SFC to the 360 SFC. Hopefully I could answer the question.
So yeah, thank you so much. And because we are thinking about how to combat better desertification process, how this water can be used for keeping cover grass and habitats moisturized, can be used these water resources and water tanks, for example, for migrating birds. Is it possible to have such scenarios for future projects?
Absolutely. Water can be used for different purposes. For drinking, it depends on the chemical quality. There must be some analysis on this, but it can be used for drinking, as mentioned by Juan Carlos. You can get beer out of fog water, but you can even get drinking water directly from the bottle, so you can drink it, you can use it for washing, you can use it for irrigating agriculture, but you can also use it for setting up ecosystems. So it's you can use it for different kind of purposes.
Yeah, yeah.
And the amount is huge, as mentioned in one, or as shown in one of the slides. We have in the region where we are working, we have up to 20 or 25 liter per day and square meter of water, and in that in a region where normally there is just 1 millimeter of rainfall. So this is a huge amount of water, 25 liter in one day on 1 square meter of this mesh. So you can imagine how big this water resource is. Well, one of the questions in the chat is if the data are public available. They are. We created a visualization tool, HTTPS.
Okay.
So we will just, Juan Carlos is just typing it in the chat. So it's HTTPS:// That's not good. Yeah. SPS://. Yeah. So if you want to have a look, you can see this visualization platform where all our stations around the world are situated. And if you look to Atacama Desert, or if you go to on the left-hand side on that menu, look for Oyapide. Oyapide is the name of the region we are working in Atacama Desert. You can explore by yourself the different fog collectors we have there, temperature, humidity, wind speed, different things.
Yeah. And are you going to use this experienced outcomes of this project in modernization with other regions, in other deserts and others, to maybe regions from in Sahara or other deserts?
Absolutely. We just have been on a fog and dew conference in Colorado this summer. So there's a specific community working on fog and dew. And dew, if I may add that to my comments before, dew is another water resource in the desert. We are doing research on that. But coming back, there is a fog conference where we meet regularly researchers from California, for example, where there's a huge amount of research about fog and fog ecosystems, but also from Oman, from India, from other parts of the world. So it's an international community. It's a small community, but it's an international community. And the projects which are applied are also around the world. One of the NGOs pushing that forward is FogQuest. So FogQuest, founded by Bert Schemenauer some 30 years ago, they are setting up such fog meshes on a big scale. So our standard fog collector is 1 by 1 meter to have it standardized, you know. But the fog meshes which are used to really produce water, they are normally 3 by 6 meter, so big meshes. And another aspect of which is influencing the amount of water you can harvest is the kind of mesh, and there's also technological research. So what is the best material for the mesh? There's different research on that. So different things can be improved still, but with a regular mesh, with a mesh of 3 by 6 meter, you can really harvest a lot of water per day or per year.
Thank you so much. Thank you so much. And a lot of questions about your intention about Mr. Alain Fowley asking about if the projects will be available in Saudi Arabia, because Saudi Arabia plans to reforestation initiatives and with the green initiative. So, and they are going to provide like a large scale projects in this time. Such projects can be identified and prototyped with Saudi Arabia.
For sure, we are always welcome to cooperate internationally. So please feel free to get in touch with me. Maybe you can type in my email address, Juan Carlos or Johan, to be able to get in touch if you're interested in our research and our outcomes. But you're especially asking about plants which can be used which kind of plants can be irrigated by the fog water. We don't make research on that, but we know from different projects in Chile and other regions on the world that different plants are used. For example, I know from one project in Chile that they irrigate aloe, so aloe to make aloe vera production.
Yeah.
So this is one of the let's say economical outcomes of such a project, that they have that they irrigate large fields of aloe to produce aloe as a basic stuff for creams and other things like that. So you would not use the water to irrigate a wheat field. The water would be too expensive to just use it for wheat. You should need, let's say, higher plants where you get more outcome of the products which you are producing.
Thank you so much. And one question regarding of using of DNI as network, scientific network, and combine with our this knowledge with future perspective projects funded by Horizon Europe. And we are very interested, and we have keen interest to build up like international consortium with Heidelberg University, and to lead some projects and programs regarding of finding water resources in deserts, management, maintain, and provide the best conservation projects. And this could be best opportunity for our scientists, and especially young scientists and practitioners, to find best solutions in this challenging time when we are scaling of water and declining of drinking water resources, especially groundwaters, because you mentioned you have provided excellent overview and showcases the best data about world situation, about physical water resources, and etc.
Perfect. Yeah, we would appreciate very much to be part of such a consortium. Maybe two things I would in this context. Some years ago, we already had a European funded project. It's within the frame of ERANET LAC. Together with Chile, Peru, and Spain, we have situated a project about fog ecosystem research and fog water production in Chile and Peru. The project has been finished successfully. So we have some partners also, not just in Spain and in Peru, but our major partners where we work very trustfully together for already 10 years are at Unicatólica in Santiago de Chile, and there they have an ATACAMA Desert Center, and we work very closely together with them. That's, for example, why Juan Carlos, he is from Chile, works at my department here as a PhD student with a DRD scholarship. So we are two partners. We are a German and Chilean German team working together very closely, but we are linked also to other regions in the world, and we'd love to be part of such a consortium to look for common European funding. Yeah, it would be great.
Yeah.
Within the European Green Deal, for example, I think this is the major aspect, because here in Europe we are talking about renewable energy, about battery-driven cars. But if you need battery-driven cars, you need lithium, and for one kilogram of lithium, you need up to 4,000 liters of fresh groundwater, and one car has 25 to 30 kilograms of lithium in the batteries. So you can estimate how much of fresh water is in each electronic car. I'm not talking about the copper. I'm not talking about other resources you need. And many of these resources are produced in Chile, in Bolivia, in Australia, so in desert regions. So it's our responsibility also to look for solutions for the people there, for alternative or at least complementary water resources, because we are using their water at the end, in an indirect way.
Yeah, well, circulate water and recirculate. Absolutely, it's a very innovative way. Also very important to use, for example, this water for drip irrigation to keep habitats, vegetation, bush, and everything we can as reforestation and providing vegetation still will be available within this provided kept water and storage facilities of water resources from fog and for dew.
Yeah, absolutely.
Yeah. So is there any questions, from my colleagues and our attendees?
I think there's nothing else in the chat. I think we have answered all the questions from the chat and maybe also your questions, hopefully.
Yeah. If we will find any question, we will provide you by your email addresses, and please provide your professional answers as you always do it with us and with our network. So, and in this regard, we are still in our impression having your wonderful presentation today for this DNI Academy, and I would like to provide information for all attendees and especially for our speakers that DNI Academy will provide certificates of appreciation to you and for your wonderful presence today. And tomorrow we will continue our work together, our active connections with in this regard to have sustainable ways in our best practices, in our everyday practices and methodologies that can be provided and developed for future projects with the Joint Research Center, Horizon Europe, and etc. and etc. So let me once again express our sincere appreciation to you and your wonderful team work to provide our members and guests and attendees about these possibilities to have this fabulous and this brilliant presentation. So we can stay and keep in touch to continue our scientific research and practical approaches to this challenging time to find best solutions in our practices. Thank you very much to all for participants and for your time and for your wonderful presentations. Thank you so much. Sincere appreciation to all of you.
Thank you to you.